personal experience and some like information with you about the chemical education. So I have been working in the field for, geez, how many years? Since I came to the country year 2000. So I have been here for 20 years. And I became an assistant professor at year 2004. So well, this is my 16 years in this profession. I have been teaching in college level for more than 20 years. So during the years, I have worked with all different levels of the students, starting from undergraduate students to graduate students, including PhD students and also postdocs. And also, well, we have some opportunities, but occasionally have the chance to work with high school students, very excellent high school students. So basically, we'll probably today, what I'm going to focus on is the AP chemistry, because that is very relevant to college chemistry and also Olympiad, chemistry Olympiad and research in chemistry here. Okay, so do you want to start with the agenda?
Yeah. Maybe we just start.
Okay, yeah, sure.
Yeah. Oh, anyone have any questions before we start? Yeah, if there's no question, maybe
Yeah.
Dr. Moses Paul.
Yeah, so we have a Q&A session at the end.
Yeah.
Yes,
So
at the end, after we present this, I will present the first part, and Dr. He will present the second part. After the presentation, then we have Q&A section. You probably have more questions at that time. And this is the agenda, and I'm going to sit down so that I can see it. We'll talk about why chemistry is important. A lot of people think chemistry is important because this is required for the high school curriculum. Second is because the probably you want to take a AP chemistry test, so help you to get into college. Right? But actually, the chemistry, why it's important is more than that. We'll talk about that. And what are the chemistry courses available? Certainly there's regular chemistry, honor chemistry, AP chemistry. And how to select the planned chemistry class. If we can, we talk about that. This actually has some emphasis by the school already. School give you some kind of guidance. What to when you plan to, how do you take the chemistry class? How effectively study chemistry? How to successfully prepare for the test? And all these. I will probably emphasize on, as I said, I will emphasize the first part. And yes, and we also talk about research. And she, the important chemistry is that we deal with chemistry all the time, and not only because we study chemistry, not only because of the requirement by the school, but we want to prepare for the test. I personally think that the important chemistry is this is a subject that will train the student's brain to think. Unlike compared to biology is a lot of memorization, memorize all this. But chemistry is understanding. Understanding that involves you have to see the problem, analyze the problem, get the answer, and get a summary. Chemistry is the course. It will you need to do this process, and by doing that, you have this what I call self-learning ability. You train to yourself to have a self-learning ability, so that in the future, when you see the problem, you know where to find the answer. You know how to summarize, get all the information, and you know how to rule out all the incorrect information, and you get all this summarized by yourself. This is the ability you should have. Chemistry is a course I think that will help you to do that. If you just study chemistry for the test or for the to fulfill the requirement of the school, I think you are missing a major part of learning chemistry. By learning chemistry, your students should be train yourself to think. Instead of just receiving information, you need to after you receive information, you should be able to think. Okay? So this is I think this is why this chemistry is important. Right? And one of the subject for the chemistry is one of the subject for the college application. Right? Depends on your major. If your student's major is going to be in history, or being law, or being art, then your requirement for chemistry may not be as much. But if you are in the science, technology, or engineer, or medical field, you will need a chemistry background. And it's a mandatory course for many colleges. This is given. If you take one of these majors, if you go into any of the college, there will be actually 1 year, 2 semesters, or even 4 semesters of chemistry required. One is general chemistry. The second year will be organic chemistry of two semesters. And it's a fundamental knowledge, critical thinking, and problem solving skill for the future career. This is what I just emphasized. They'll help you, help the student to train their skill. So in the future, when the student get out of school, when they face when she or he work in the company or in the laboratory or in any field, he or she will encounter a lot of problems. What is the student should have the ability to say, okay, I have this problem. I know where to look for the answer. How do I summarize from the answer I got and learn from that and solve the problem? That is the skill the student should have. Okay?
For some college, like if you learn law or history, may not need to require chemistry. But you apply some top college like Stanford, if you haven't studied any chemistry, your chance is 0. Depends on the college.
Yeah. What Sherry says is that some of the school will even require the student to have a chemistry background even in the high school in order to apply. Okay? We'll see that. So this is from Princeton. Exactly from Princeton. What it says. It says, if possible, we expect the student to complete the following course before begin study at Princeton. That means they expect you have all this at high school, like 4 years of English, including continual practice in writing, right? 4 years of mathematics, calculus, everything. Wow, this is a lot for high school students. Right? As for a student who are interested in engineering, 4 years of foreign language. That's a lot. That's a lot of requirement. But it is from Princeton, and at least 2 years of laboratory science, including physics or chemistry, and student who are interested in engineering. So that means you can 2 years. You can take 1 year of chemistry, 1 year of physics. But that's what's required. They when they receive application, they will look at the curriculum of the student who are in the high school. What are the class they have already taken? That's the requirement. Right? Because they say, if possible, we expect students to do that. Yeah. So it means this is what they're going to screen out. There will be hundreds of applicants. This is probably they're going to screen out in the first step. Right? And this is from CMU, Carnegie Mellon University. College engineer, the high school course requirement, 4 years English, 4-year math. That means you need to take math every year in your 4 years of high school. And 1 year of chemistry, 1 year of physics, 1 year of biology, 2 years of foreign language, and 3 elective. Sorry. If you are in this is for engineer. If you are emphasizing, say, I want to go to computer science. Computer science is doing a lot of coding. I personally don't know why they require 2 years chemistry, but it's written right there.
2 years of
2 years of chemistry. Oh, okay. 2 years of chemistry, biology, or computer science. I help you to get into the college. Now we talk about we have a very good high school around here in the Bay Area. What they offer, the student has regular chemistry, they have honor chemistry, they have AP chemistry, class being offered. AP chemistry, regular chemistry is you can take even in 9th grade. That requirement is just what we will teach is pretty much just a basic chemistry. I've been tutor people from student take regular chemistry. I also have tutor people from taking honor chemistry, and I also tutor students from already taking AP chemistry. At the same time, I already know there's a lot of difference. The one from the general chemistry is slower. The pace is slower, and the way the area they cover is less. And then for the for the honor chemistry, a lot of students tutor take honor chemistry. They expect the student at 9th grade can start taking it. The requirement is simple algebra. You should have already taken the algebra, and it depends on high school. And who is the chemistry teacher? The amount of the material covered in the honor chemistry is so different. Depends on the school and depends on the teacher. I would say more depends on the teacher. And for the AP chemistry, they say usually it's like a 10th or 11th grade, which I agree. That means if a student never touched chemistry, wants to take an AP chemistry directly, I think it's kind of hard. It's a lot of material to cover. There are more material to cover. The pace is faster, and I would think the teacher will expect the student already have a chemistry background. So what they do is okay, this is my chemistry class, AP chemistry class. I have my prerequisite. If you student come in to take it, I will teach the way I teach. I really don't care if you can get it or not. Right? So for those people who are intended to take chemistry, AP chemistry before, if they have not really touched any, do not have any chemistry background, I would think it's difficult for your children. Right? But when I tutor a student who has taken AP chemistry, I said, well, did you take any other chemistry before? She said, yes, I took other chemistry 1 year, and then now I'm taking AP chemistry. And it's a challenge and a rewarding for the college application. AP chemistry, if you take AP chemistry and take the AP chemistry test, and if you have good grade, then it will help you on your college curriculum. And it's a training critical thinking and analytical skill. So AP chemistry going deeper and wider area and going deeper. So there will be a lot more material to cover. So this is the regular chemistry, honor chemistry, and the AP chemistry. And this is more detailed. It's like the content, the detail, the difficulty, analytic skill, problem solving. In the scale 1, 2, 3, 4, 5. 5 is the most difficult. 1 is the easiest. This is pretty much a very, very quick overlook comparing the AP chemistry and the other chemistry. Most of them, each of these categories for AP chemistry is more like in the category 3, 4, and 5. If you take other chemistry, is good for the SAT 2 chemistry test. But it also depends on the school and on the teacher. But for AP chemistry, it's much better, and study together with the AP chemistry will boost your GPA and the honor class. For the AP chemistry, there's what they call 6 big idea is standardized what material need to be covered in the AP chemistry. It's a 6 big idea. You can look online. So you cannot say, oh, I teach chemistry, I arbitrarily call this as AP chemistry. You cannot do that. You have to have at least cover those 6 big ideas. That's for AP chemistry. But for the honor chemistry, they don't have the standard rule. What need to be covered in the honor chemistry is more like it depends on the teacher. AP chemistry has the standard rule. What need to be covered. Okay? So, if you take elementary AP chemistry as it improves your GPA, that is if you have good grade. Okay? Admission is plus. College has a credit, certifies the requirement.
For the GPA is weighted GPA.
Weighted?
Yeah.
Yes. Okay. Now, there's 6 big ideas for AP chemistry. I will turn that to Dr. He. She will be focusing on AP chemistry.
Thank you. Great. Thank you for all the information. And so now I'm starting to talking about the AP chemistry. So what is AP chemistry? Well, actually, I talk a little bit of its equivalent. So we know this is advanced placement. So the class that is place equivalent in college is called chemistry. So general chemistry actually is like a fundamental class. Typically, the students will take the first year. It covers 2 semesters. Typically, that is our like 103, 104 course. And why this class is very important? Because it's a fundamental to all the rest of the chemistry and the chemistry-related course. So it is a prerequisite. So for example, if you don't take general chemistry or equivalent to this one, you are not eligible to take other class like organic chemistry or the analytical chemistry or some other related class. So this is our prerequisite. Okay, so in terms of the content of the AP chemistry, so like what Dr. Ho mentioned, it covers 6 big ideas. So this is a general guideline. But actually, if you look at this big idea, it's really big idea. It tells you the big picture of chemistry. It's talking about actually everything. So actually these 2 slides are very chemistry. So for example, the atoms, elements, periodicity, chemical bonding, reactions, energy change. So this is just a little bit too details or too technical for the regular audience. Well, actually, these big ideas, these 6 big ideas, actually, I can see that it covers almost most of the aspects of chemistry. Well, it's talking about starting from talking about the atoms, the building blocks of the matters, and then to the higher level, to the molecules, and then another level, molecular interactions. So how molecules interact with each other, how the reaction can happen, and why the chemical reaction can happen, and how fast it can happen. So all these type of the questions. So that is covered by the 6 big ideas. Well, actually, no matter which idea, if you dig deeper, well, actually, it's going to be an entire research field. So specifically for us, for the AP chemistry, which kind of the topic, very specific, detailed topic that is going to be covered. So I selected some of them. So for example, it's a matters and measurement, so that is the basic fundamentals. Like stoichiometry, that is very important. And chemical kinetics, that is talking about how fast the reaction happens. And like equilibrium, which tells you how the, after some certain reactions and how, what's the final state it can reach. And also something like electrochemistry. Well, you can see that all these topics are covered under these 6 big ideas. So you know in our textbook, typically the electrochemistry is chapter 20. Well, basically there are a lot of content. So a lot of topics. So definitely it's very challenging for high school students. So not even high school students, even for the like freshman students, graduate students, this is actually this is also a big challenge because of the scope of the materials, the content, and also the depth of the materials that is covered. So basically, these are the specific topics or the knowledge point that we expect students to understand for taking the AP chemistry. So not surprisingly, because of the scope and the depth, typically this is the performance of the AP chemistry test. So cumulatively from 2012 to 2019, if you look at the chart, and for the very top, so the five points, so only 11.5% of students can achieve 0.5. So, well, basically this is a relatively low number, especially if you compare with some other course. So this is a hard course. This is a very challenging course. Sorry? I think, so Sherry,
why start what's your question?
the question,
From because AP chemistry reformed.
what's the statistic? Yeah.
This is from College Board. You can get the data, this is public data. You can go to College Board website to get all of the AP subject test result.
Okay,
Not
so
from us. Yeah.
all in all, this is a very challenging, very difficult class. So no question. Okay, so maybe probably some of you already know what's the meaning of each of the points. What's the great the meaning, but still I want to do a little bit of interpretation. So just in case if for some parents or students, it's not very sure about what the score means. So first of all, if you have a 5 score, which means extremely well qualified, excellent, outstanding, so that's equivalent to A in a college transcript. Well, or in our types of in the grade that we give to students. So if you have a score 5, so that is a very good one. And score 4, which means the student is well qualified. So well, that equivalent to roughly like a B grade. And if you have a score 3, which means the student is okay, is qualified. So basically, you can pass the class. However, it's not a high pass. You just pass the class. So this one is roughly like a C grade. Well, 1 and 2 is just very low numbers. So then if we come back to look at this chart again, and then you can see that only small fractions of the students is in the top, the 5 score grades, and some of them is 4, and the majority actually is in 1, 2, 3. So basically, this is the situations for the AP chemistry test. So because of this reason, well, I think everyone has to get prepared. So this is a very challenging test. So in terms of the content, how the test look like, well, basically for the AP test, typically the test is held in May. All the AP test is in May. And it includes 2 parts, part 1 and part 2. So for each of the part accounts for 50% of the grades. So for the part 1, it contains 60 multiple choice questions. So you just choose one from ABCD, and that well, basically it gives you 90 minutes. So well, that requires you that has a very fast response. So when you see the question and then you need to reach the answers, correct answers in the relatively small period, short period. And the part 2 is also 50%. So for part 2 question, well, that consists of 7, we call it free response questions. So free response questions, well, it's typically like our 问答题. So the top one is the multiple choice in the 选择题. So this including 3 big questions, 3 long questions, and 4 shorter questions. And the total time is 105 minutes. So this one actually including the knowledge required the student have a very good understanding of the lab operations. Because some of the questions, the long questions, it's in the form of describing as what you have done in the lab. So you should interpret and understand what's going on over there. So basically this is the AP test, what we had and how the scores were counted. As a comparison, SAT2 test. So SAT2 test is much more straightforward. It only contains multiple choice questions. Well, the time is shorter, but definitely the question is also less difficult. It's easier. And in terms of the test date, so for the AP test, I think once a year in May, and for the SAT test, there are multiple test dates available around the year. So basically, you can have a more flexibility on choosing the test date. Yeah. So here, this one is what to expect from the AP test. So because here I want to focus is on AP chemistry test. So for the SAT2 here, it's just like a comparison. For the AP chemistry test, the first part, the multiple choice question, so typically it shows up in 2 forms, even though they are all multiple choice. The first one is a single question. So when you have so this one is just ask a question and then you choose. The other type is a group of the question, but it's based on the common statement. So basically here is a statement, and then there are several questions will be available, ask you from the different angles or different approaches about this statement. So these are the 2 different types of multiple you can have in the multiple choice question. And for the section 2, free response questions, yeah, like what I mentioned. So some questions are very experiment or lab oriented. So that is preferably you have a clear picture of what's going on in the mind, and also the score, how the test being graded. So that is the basis of accuracy and relevance. So the good thing for the second part is you can earn the partial credits. So if you have something wrong, it's okay, but the right part you can get the partial credit. So and also it's also including the explanations, the free response, the writing part. So the writing part are expected to be very clear and organized. So in this case, well, actually the writing is very, very important. So you can imagine that. So when the teachers start to grade the papers, if you have a very lousy writing, well, actually that's going to directly impact on the feelings of the graders. So then in this case, I want to emphasize the writings, importance of the writings on the free response questions. And also for the calculation part, so you are supposed to show your work. So step by step, show your work. So logics of the thinking is extremely important here in order to get a high score in the AP chemistry test. So on top of the AP chemistry test, especially for the outstanding high school students, we also have the opportunity to participate in Olympiad competitions. So for the Olympiad competitions, that including 2 levels, the local level and the national level. So for the local Olympiad test, typically is in March. So basically, it's going to open very soon. And the format of the local test is relatively simple. It's a multiple choice. It including 60 multiple choice, and the time is a little bit less than 2 hours. So the purpose of the local test is to basically select the top participants for the higher levels of the computation. So typically, 2 students were selected every school. So if your school is very competitive, so the computation in terms of the goes up to another level will be really challenging. So if you are the lucky 2 students, and then it can be promoted to the can be advanced to the national test. The national level test is in April after the local test, and this the national test actually including more. So basically, we want to evaluate students from more aspects. So that's not including the multiple choice, but also including the free response questions and also experiment. So students are expected to do something in the lab. They really do work in the lab. And then after the test, well, basically, depending on the result, the final result, the students can get the honors, high honors, or enter into the national camp. And I think in summer, in June, the selected students, if they are in the camp, so they can attend the international competition on behalf of the US. So basically, these are the Olympiad. So the Olympiad questions will actually is also it's rooted on AP chemistry or general chemistry. However, it's even in a much depth in terms of the knowledge. So if let me say for the AP chemistry, that's equivalent to the freshman college chemistry course, the first year students. For the Olympiad computation, I would like to say it's a high, like a senior or junior year students levels. So in addition to the general chemistry or the basic chemistry covered area, in the Olympiad computation, also including the coordination chemistry, organic chemistry, and some knowledge on the biochemistry, and also including the lab. Lab actually is very important because chemistry itself is a lab-based science. So experience and working in the lab is extremely important. And here also I want to share some of my own experience. Well, actually the difficulties for the Olympiad test is getting harder and harder. So my feeling is that year 2009 is like a cutting point. Before year 2009, it's okay, it's relatively easy. So it's much more like our general chemistry. However, after year 2009, I can very easily feel that it's getting harder and harder. And sometimes it even touch the, like for example, our advanced inorganic chemistry content. Another thing that if you attend the Olympiad test, that require you very strong calculation skill, not necessarily math skill, but a lot of calculations. Very calculation heavily laden. So almost majority of the question you need to do a calculation. So you have to be very fast, really fast, very good at calculations. Well, so here is a comparison of the questions that show up in the SAT test, AP test, and the Olympiad. So all these questions are talking about acid and base. So this is a fundamental area that will be tested. However, for the SAT, it's just like a common sense, the knowledge. You will take a chemistry class, so this is not a big deal. However, for the AP questions, so you need to think about what's going on here. But for this one, you need a lot of calculations. Not only understand what's going on, but also you need a lot of calculation to figure out, quantitatively describe what happens. And also for this one, it's also not a simple like a monoacidic situation, but this one is more complicated. Well, so basically that's the comparison. Even though the knowledge point that the test is acid-base in the same area, however, the question can be asked from very easy to very difficult. Okay, so here is some of my own experience on how to study chemistry effectively from my point of view. So first of all is the math. Math is important. Math is actually the fundamentals for all the advanced STEM educations. So typically we require algebra 1 and 2. So students should be very comfortable on the algebras. And the second important thing is understand, memorize, and analyze. So here I want to emphasize understand. So in chemistry, there are a lot of knowledge points. So you need to memorize, no problem for sure, you need to memorize. And however, this kind of memorize is not the simple mechanical memorize. So the memorize requires you understand. You have to know why. So after you understand the why, what's going on behind the thing, and then you memorize, you will know what's happening. And then after that, and then you apply your knowledge and to study the new. When you handle the new situations, you are able to know how to handle this kind of the situations. So, for example, in one of the chapters is the periodicity of the elements. So, when you study, for example, one group of the elements, so if you know one element, so for example, sodium element, so why sodium element has one charge, and if you understand that, and then, so first of all, understand, and then you memorize, sodium has one charge, positive charge, and then you can apply to analyze to the rest of the elements in that column. So basically, the thinking and understanding is very important. Well, obviously, there are a lot of like formulas, equations, you need to memorize, and sometimes you have to be like learn by your heart. When you see something that is just like a natural response and you know what's going on. But that one requires a lot of proficiencies. So how the proficiencies come? Well, proficiencies coming from practice. So similarly to any expertise. So if you want to be good at something, and then you have to practice, 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 and practice. So here I want to emphasize and highlight the importance of the practice. So typically, we encourage students to read the book before the class. Well, actually, I think this one applies to many of the course study, and if possible, you can do some exercise and check what you understand, what you don't understand. So this can be served as something like we call the pre-test. So basically, you can pre-evaluate your ability, your performance, and then after that, you go to the class. After the class, do the review and do the exercise, do the homework. So sometimes I don't know, maybe teacher assign you the homework, but sometimes may not. So then in this case, probably you need to find more problems to solve by yourself. So this really needs the motivation of students itself. So at this level, well, basically, parents always eager to help, so want to push, but I feel that the student self is more important. So student has to be self-motivated. If he want to learn, he or she will just try all the best and to find all the resources. We have plenty of the resources to support the study, but the most important thing is that you want it. Okay, so do you have any questions so far? If you have questions, so welcome to interrupt at any time. Okay, so this is last slide. What I'm talking about is for students. So how to study, how to prepare before and after class. And another thing that I want to share or mention is that probably we can also arrange it. We have a strategy. So work with our timelines. So make our effort have the maximum benefit. So here is the timeline of several of the important chemistry tests. Well, the first one I put is the school chemistry, obviously, where you take, at the school you have the quiz, you have the exams, you have all these school requirements. And time-wise for the Olympiad, so it's every March, every spring, every March. And for AP chemistry, it's May. So for this year, it's May 7th. May 7th, 2020. And for the SAT test, I grabbed up all the SAT tests available for this year. So we have May 2nd, we have August, October, November, December. So it's good. In the fall semester, you have... Yeah. What? So there is a, yeah, so typically, the point is that there are a lot of opportunities for the SAT test. But I think for the most efficiency arrangement probably is when you are taking school chemistry now, and then you start to prepare AP chemistry for May, and then you can take the May, you can take the test for the AP test in May and SAT right after. So all together. And if you are very strong students, and probably in the March, you also take the Olympiad. So then in this case, when your mind is very fresh, when all the knowledge is very fresh, and then you can do all these kind of things all together instead of separately. So you can imagine that if you finish your school chemistry and then you take the chemistry 1 year after, so probably half of the knowledge already gone. So if you want to prepare for the exam, you have to fresh up again and pick it up again. So in term-wise or efficiency-wise, well, my suggestion is that try to arrange all these things together, line it up, so that within the 1 year period of time, and then you can achieve the maximum in the shortest time. Well, basically everyone has very limited time, and we have to be effective. Okay. So this is how to work with the timeline. So the plan is very important. So you may want to start plan ahead, plan in advance. Okay, so far what I'm talking about is AP chemistry and Olympiad competition. And Sherry especially want me to talk about the scientific research. So here I just share some of my personal experience and the knowledge, so how this information will be useful to all the parents. So for scientific research, well, actually, typically, that is for the graduate school kind of a thing. Well, in the graduate school, when you are the graduate students, most of the graduate students are expected to conduct some certain levels of the research work. Even though there are some program, it's only course-based. You can get a master's degree only by taking the course. But for many of the graduate program, especially in the STEM field, you are expected to take the research. So previously, the research is very privileged to the graduate school. However, the trend getting changed. So in the past 20 years, so more and more undergraduate program is promoting the scientific research. So more and more undergraduate students is getting involved in scientific research, very serious research. And also even now penetrated to the high school. And the high school students are also encouraged to participate in scientific research. So the question is why? Why we want research? So why we want to emphasize the research? So probably in order to answer that questions, probably we have a look at of this figure. So probably maybe did you know this one? I'm just curious. Does anyone heard about this? The Bloom's taxonomy? Have you ever heard about this or never? This is very famous in education. So what levels of the learning that a student can have? So typically, based on this classification, typically the learning can be classified into the different levels, 6 levels. the level 1 or the lowest level is remembering. So, and the higher one is understanding, and the level 3 is applying, analysis, evaluating, and creating. So for the traditional classroom education, so basically the professor is do the lecture and the students sit there taking the notes. So that is a very classic classroom practice. So that is actually focused on level 1 and level 2. So through this practice, the students typically understand what the professor or what the teacher talking about and remember a lot of things. Well, these are the fundamentals. However, the drawback is after some certain time, like after 1 year, probably most of the knowledge has been forgotten. So just let's recall how many knowledge that you learned from your undergraduate study. How many knowledge you still freshly remember today? Probably not much. So, well, basically that is kind of not very efficient in terms of the education. So the higher level is applying and analyzing, and then how to do this? Well, typically all these higher levels of all these higher levels ability is the very essential ability that can help us to facing all different types of the challenges. So this typically is through like doing something, or you look at something. Well, typically the arrangement is listening, looking, and doing. So through learning through listening, probably you forgot math. Learning through watching, you can retain more. But the most effective thing is learning through doing. So basically you participate. You are the owner of the knowledge. You are the people to create the knowledge. So these are the higher levels abilities or the skills that we expect from the education. So it's just like us here, the Silicon Valley. So the technologies created by Silicon Valley has so much impact on our society in the past 20 years. So how many models has been changed, and how many new jobs has been created, but how many old jobs has died, basically isolated. So basically that is what coming from here, the creativity, the innovations. What we highlight here. So every person here probably is not very familiar with the word of innovation, creativity. So if you are in the company, probably, what's your idea? What's your creativity that you have? So basically, that is our goal for the education. We want to cultivate our students, educate our students, to let them master the skills that they can use in the whole life. So I remember the other day, last year, I invited the director of science at Johnson & Johnson, so the pharmaceutical company. He is the person who is in charge of the North America operation in scientific R&D. And then I asked him to go to my give a talk to my class. And then he said, well, the techniques that we use nowadays is different with many years ago already. So what we expect as an employer, we hire students, we expect students know how to face a new challenge, solve a new problem. So that comes from the creativity and the thinking, critical thinking ability. So basically, the top of the pyramid is the goal of our education. So then how to implement this, how to realize this goal. Why it doesn't move? Okay. So basically, we want our students to equip it with the knowledge and the capability that can benefit them lifelong. So this is the reason why we promote scientific research. in college now, even for the undergraduate students levels. So nowadays, if you go to a college, you can find a lot of opportunities for research in the different places. So depending on which college that you are in, so if you are in a relatively large, middle or large size of the universities, so typically you can find the undergraduate research program. So that is designed by the faculty in the university to help their students to do the research. And also in a lot of universities now encourage professors to integrate research into the curriculum. So basically now we are not only limited to traditional lecturing, so actually that is a kind of like old-fashioned teaching. So we are encouraged to integrate the research into the classroom, into the curriculum, so that more students can benefit from this process. And for some smaller universities, they have limited capacities for research. Typically, they can the students can participate in a centered research program. So the centered research program typically is hosted in large universities in the region, and usually this kind of program is for summer participation. So the students can apply, and so we call it PUI. PUI is a primary undergraduate institute. When they don't have this kind of the research capability by themselves, their students can apply to the centered research program in other universities, and during the summer they go to other institutes to do the research. So basically a lot of opportunities are available for students to do research at the university nowadays. So, however, even though we try to promote, encourage students to participate in scientific research, however, this is still a very selective process, not everyone. So there is still some like privilege, but still it's not something for everyone. We typically, there is a student selection process. So here I just want to use some example. The typical process. Maybe there's some difference. It varies from school to school, from university to university. However, typically this is what's going on. Usually the students at the end of the first year at the college, so they can start to participate in research. So for this program, they can apply, and then we have some certain selection criteria. So for the very excellent students, maybe sometimes we reach out to invite the students to attend, but in most cases, the students have to show their interest first. So if they are accepted by the research program, basically they are going to have the training on how to do the research and also participate in the project. So typically they are going to stay paired with the professor for 2 to 3 years, and during this period of time, and they are expected to learn all these research skills. And by the end of the 2 to 3 years, or when they are in the senior year, and they are expected to have some certain achievement. So the achievement including, for example, they are able to produce some results that is presentable to present at a conference or working with a professor to have some certain like publications or something like that. So this experience actually is very important for students to apply graduate school. So that is a stepstone for the graduate school applications. So the research experience will significantly, not a little, is significantly enhance the possibility to be admitted by the top university or program. So here the key word is research experience, significantly enhanced, and the top. It's top. If you want to go to a top university, you have to have the research experience. So, well, obviously this is a requirement for the graduate school admission. However, the same idea applies to college applications. So for the very outstanding high school students, if you have some research experience, it's going to help you to stand out in the entire application pool. So you can basically replace this word to stepstone to top university. Okay, so in addition to the college admission or the graduate school admission, for me, actually I'm more worked with students for the graduate school applications, but still actually it's the same. So this is something I really want to share with you is what evaluation criteria is used in higher education in this environment. So how to select the talent, what's the process? Well, based on my experience in the past 20 years, well, actually, I feel that this can be summarized by two words, two phrases. One is called intellectual merit, another one is called broader impact. So what does that mean? So for the intellectual merit, well, actually, it's reflected from your, well, for the students, it's reflected by your GPA, your test score, your computation, your well, research is part of that. So how good academically, how good you are, what the GPA is. And for us, for example, for me, I take my undergrad study in China, and what I'm familiar with is, well, different with the system that we have here. So probably for parents in my age, we are much more familiar with the test, with the score, with all this kind. It belongs to intellectual merit. It's important, very important. However, it's not enough. Another equivalently important part, we call it a broader impact. So it's like a 50-50. Broader impact, so what does that mean? So for broader impact, it can come from the two aspects. The first aspect is what is your intellectual merit impact? Or in another word, for example, if you do a research, and then what's your impact of your research to development of the knowledge, to contribution to the development of the new field. And in addition to that, another broader impact is what's your contribution to the community, what's your contribution to the whole society, how you can affect others. So what we expect here for the student, for the talent, for the top, especially for the top student, what we expect is that not only you are excellent by yourself, you have to affect other people. So you have to be like a role model, and then you have to help other people around you to build a better society. So this is our broader impact. So this is the reason why the extracurricular or the 课外活动 so important here in college application. So this is something that we are not very familiar with, but it's very, very important, extremely important, because it shows your social commitment. So this is basically what we want to emphasize or highlight. So actually, this rule is not only applies to college application, but the college application is just one of them, one case. It also applies to similarly graduate school application in the future. If you want to apply graduate school, same thing. You have the statement, you have all the GPAs, all the grades, and all your awards, and then you have the broader impact. What's community outreach you have participated? How you help other people. When you have the greater ability, you are expected to have share the greater responsibility. And also the fellowship application, etc., including actually the tenure application if you happen to be a college professor. So in recent years, actually, I was sitting in a board to review several of the fellowships, the national fellowships, and I have the opportunities to view the applications from the very excellent, very outstanding students and students and including some of the postdocs, graduate students, PhD students. And well, actually, my feeling is for some students, for the students that is grow up in the U.S. and educated through this system, the excellent student is truly excellent. The outstanding student is truly outstanding. So not only intellectual merit, but also the broader impact. So you can see that it's a very fulfilled, developed personnel, and that is what we can expect from the leader. And for the application from students, some of them is have their undergraduate, for example, from China or from other countries. What they can present is, oh, I have publications. I have 10 publications, but nothing. After that, it's nothing. So that is the difference. So when we evaluate students, and then we have to weigh out both parts, especially if you want to go to like a mainstream media for evaluation, both are important. So probably for us, traditionally for our culture, maybe we focuses more on the intellectual merit, focuses more on the grade on the test, but some kind of last rating on the broader impact. But this one is very important. So here, this is what I want to mention, and to let you be aware of that. It's frozen. Oh, sorry, the computer is a little bit. Computer is a little bit slow. Okay. So now we come back again, the intellectual merit, because we want to outstanding among the poor. So basically as a parent, when we prepare the package for college application, what you have to bear in mind is that how make me stand out? How can make me stand out? So definitely the scientific research for high school students is a factor really can make you shiny and gain the advantages during these competitions. So typically for the high quality high school research, we can typically expect the outcome like if you have some product, if you participate in some product, and then you can use this one to participate in competitions. So we have all the different types of the competitions, science fair, and so on and so forth. And also you can do presentations. So in the regional or the national, preferably national, but if not, national presentation is good too. So for example, the ACS meeting, American Chemical Society, it has a annual national meeting twice a year, but has a lot of regional activities. And also, if your research result is really good, so maybe your professor, your mentor can invite you or include you as a co-author of the paper. So basically, all these are the very good outcome from the high quality high school research. So this is something that is tangible, but definitely that requires the students' engagement and the participations. So this is hard. This is not easy. But it's really a reward during this process. So in terms of the research, it's common to come up with a quick question of how to do research, where to start with. So first of all, what I want to emphasize is reading and writing, scientific. But here we have scientific reading and writing. The scientific reading and writing, especially writing, is different with the regular writing that we have of what the students are familiar with at school, because it's totally different. It is a totally different categories. And typically, if you want to start a research project, the first thing that you are going to do is to do the literature research. So for the high school students, most likely, your mentor will give you several of the papers that you start with reading of the papers. So but eventually the students are expected to learn how to do the research, literature research by himself. So this is the first things to do. So you are expected to read the research paper and get the knowledge, key point from the paper that you read, and then summarize the point. And all these are the very basic skills that I expected to obtain. So this is the training. So when we have a student in a research program, it spent 2 or 3 years. At the very beginning, actually, we trained them. What we did is to train them how to get started. So basically, reading and writing are extremely important. In addition to definitely if you want to start a research, it's a very essential. This is the #1 skill that you should have. And on top of that, even you just enter into the college, so you are going to the students will feel the transitions, the difference between the high school and the college, and a lot of the expectation will be different. So at the college, the students are expected to learn by themselves, very independently. So basically, professor would not like spoon feeding the students, give you all the knowledges. So you are supposed, the students are expected to figure out a lot of things by themselves. So very typical, the students will get the reading assignment and the writing assignment. So probably it's for sure every class. So for the reading assignment for the science class, so for example, the chemistry class, you are expected to read the scientific literature. So for this reading assignment, probably the professor give you the papers that all the materials that he help you to accumulate it. But in a lot of cases, it just give you a topic. So I'm going to cover this topic next week. So you are you search for some of the papers readings and get prepared for my class, for my next class. And also including a lot of the reviews books, basically a lot of readings. So have to be prepared for that. And for the writing assignment for the chemistry class, well, the #1 writing is lab report. So then you have to know how to write a very good lab report. And as I know, some of the students struggle and cannot get a very good score, overall score on the chemistry class is because of the lab report. Cannot get a good grade on the lab portions. So this is a very important part. And typically, we also have the writing project every semester, and the students are expected to write a term paper. So all these are like a basic trainings for the for prepare for the higher levels of the study. However, here I want to mention that there is a gap between the regular and the scientific reading and writing. So, well, actually, this happens to my students all the time as well. And this is also what we try to help our students. So what's that? So because even though the students take like language arts, take the English, so these are the very traditional reading and writing training. So that's a literature. So that is a different category or different field. But for the scientific reading and writing, so there is a different format. So how the way the information has been organized, so that is totally different. However, because most of the time, because of the time limitation, the professors would not teach you how to read and write in a science class because what they expected you know something. You already know reading and writing, but actually the fact is that the students don't know. So this is something that they really need to learn, either by themselves, or by through some certain approach or certain help. So this is what I want to emphasize. And finally, here I have a slide that have the research opportunities for high school students. Actually, there are a lot of programs available in the country and in the California state. So, for example, the SIF, the Science Internship program, so that is open for the high school students. So for this year, typically the application process is very similar to college application. So it starts from the earliest spring, like January, February. Most of the deadline will actually is in January or February, and sometimes it's open to March. The late one I saw April, but it's very rare. And typically the project, the program will start when the regular school year ends. So like at the end of the May or beginning of the June, and through the summers. So this is the science internship program. Another one is the Cosmos. So this one actually is pretty competitive. The acceptance rate is relatively low. So this is California State Summer School for Mathematics and Science. Well, basically you can get all these informations from the website, and then select the program that fits to your need. Well, definitely you can also contact with the professors and see if there's any opportunities to participate in the research. Well, okay. So probably I just stop to here, and this is some of my personal experience on thinking. So hope is helpful to you, and so now I'm going to switch the gear to Sherry, and so this is a Q&A. I'm sorry, so probably I talk too much. Take too long time.
Yeah, so just any questions.
Thank you very much. Thank you for your time. Especially today is a Chinese New Year. So yeah, first of all, Happy New Year to everyone here. And yeah, thank you for spending the morning and take time from your busy schedules to attend the seminar. So if you have any questions, and if I can answer, I'm happy to do it. Yes?
The AP chemistry lab section, how do you think it can help students?
For the labs.